Welcome again to ACE 2025. Very excited to be here. Exciting day 2 ahead. I hope everybody had a great time at the reception last night and a great day yesterday. I know I did. Got a lot of good meetings in with customers and good conversations going. So let's continue that community feel. We all appreciate the openness and community effort that everybody puts in. It is a great privilege to be here again at ACE. I can say that I have been to many ACEs, as I'm sure a lot of you know. This is actually the first ACE that I've gone to that I did not have to get on an airplane for. It's great. It's great to be here in Boston, where I make my home in this area, and it's great to be part of the tech community in the Boston region. For those of you who are not from this area, it is a very vibrant tech community. Lots of academia, lots of involvement with the tech community with Aras here. So I hope you all get to get that feel, understand a little bit more about this beautiful city, and get to see it a little bit while you're here. So, as I mentioned, I've been with Aras for most of the past 25 years, not quite all of them, but most of them. And what I found over time is that this community is just such a curious bunch. You know, we're always asking how to do things differently and how to do them better. And as Leon and Josh alluded to, that always starts with a what if. It always starts with some new way of thinking, a new way of approaching a problem. And we're proud here at Aras. We're proud of what we've been able to achieve in that sense. And we're proud to be celebrating 25 years of asking what if. So normally I spend this whole time talking about the future, talking about what's coming next, but I wanted to go back and do a little bit of a retrospective on what was going through our heads at Aras, based on the feedback from this community, what we were thinking at different points in time throughout our history. So let's go back in time and look at those questions. So 2001, I wasn't quite an employee yet. But in many ways, I was already part of the community. I had worked with Aras founder Peter Schroer at a previous company, and we'll talk a little bit more about that later. And really, we were talking together about what could be. I'm not going to take any credit for this because I wasn't here, but I was a big fan of what they were doing, watching it from the outside, rooting for Peter and the team to get a foothold and get going and really make a difference in the world of PLM. At that time in 2001, the web was really starting to take shape. Of course, we were on the backside of the internet bubble, but the web, the ideas of building web-native capabilities were really starting to invade into the enterprise software space. You saw a lot of companies trying to build a browser-based front end to PLM and other enterprise systems, browser-based user interface, but the back end was always the legacy stuff. And so in 2001, what we were really thinking is, what could we build? What if we could build a web-native platform that was really services-oriented and had the design patterns more like a web-native technology? And I have to say, that has served us very well for the past 25 years. The fact that we were founded at that time really helped us to adopt new technologies quickly and has helped us in this shift to cloud and SaaS. And so really this has been the foundation of what we did was this flexible web native platform to address the inadequacies both of the technologies of the time and the philosophies of how the companies that were building very inflexible, very static systems. Fast forward to 2005, now I was a couple years into my tenure at Aras. And we had built up a set of platform services, you know, the things like workflow and access control and search and all those things that underpin the platform. We had a lot of the concepts and have built out a lot of the low-code modeling capabilities. Of course, we didn't have that name back then, but we had all the foundational things that you know and love with item types and relationships and workflows and all that good stuff in the core of the low-code modeling capabilities. The time had come to ask, what if we could build a suite of applications on top of that platform that could really work together? And this has been, again, a foundational element of the way Aras approaches the problem. It isn't a set of capabilities that were gained by acquisition. It's not a bunch of separate technologies with integrations. Everything was built on the same platform. And the key to that is that shared data is actually shared. It is the same data when you're traversing or navigating between the different applications. You're working on interrelated data that we now call, of course, the digital thread. So this allowed us to do things differently. So we built applications that worked together. We built applications that had new and different kinds of features because they could work together. Because, for example, quality could work with manufacturing planning. Those applications are always working in sync, and we're having a different experience for the user because of that. If we fast forward to 2011, by then we had this rich suite of applications, the product engineering and program management, and by that time we had quite a few others. We were asking ourselves, okay, now how do we best leverage the digital thread to make impact analysis simpler? We came up with this idea of the impact matrix. It was born out of this what-if thought process. What if we could make it more interactive? What if, as you add things to the list of impacted items, what if the list of possible other things that might be impacted would be dynamically generated? And so it becomes more of a wizard-style impact analysis that really has, we believe, helped the industry move forward in understanding the connections in the digital thread, understanding really the impact of change across an organization. And we're still looking to get better on this. Your feedback is always welcome, of course, and you look to the roadmap for more change management improvements that will take this, we believe, to the next level. 2014, I think, was an important step forward for us. Of course, the rise of social media in the late 2000s and early 2010s had us really thinking about new forms of collaboration and how that will impact the day-to-day work of our customers, the engineers who are doing the work in PLM. But we heard from the community that it's great to have collaboration, but what about security? What about IP protection? We can't just have random conversations where individuals can accidentally leak information that is trade secret or export controlled or classified in some manner. So the idea that we needed to build this capability into the platform became very real. We were asking, what if we built this into the platform in a way that every user could have access to that, to the collaboration, so everybody has access to the thread of discussion. Everyone has access to the view and markup, both in 2D on top of a PDF, for example, or for 3D. So everyone in the organization, not only engineers, would have access to the 3D data and would be able to collaborate back and forth about it. So we thought that was a very big thing, and it really extends out beyond the traditional PLM audience. So you can bring in people from the manufacturing shop floor, you can bring in suppliers, you can bring in others into that collaboration session, and it keeps everyone in the life cycle fully engaged and collaborating in the context of the digital thread. So anybody who is working in visual collaboration, they don't need to know the names of everybody that has ever touched this bill of material, for example, what they need to know is they're collaborating in the context of that bill of material and know who the ownership is by nature of being able to collaborate with them through this mechanism. If we move forward a few more years to 2021, now, of course, we saw the demand for cloud technologies and SaaS delivery models in the PLM world. It came a little later than in most, and there were good reasons for this. Of course, everyone wants to talk about IP security, intellectual property, and security, but that's not the only reason. Another big reason was that companies really needed to be able to have customized solutions. They needed to have the security and scalability and all the resilience that comes with a cloud-based environment, but they couldn't give up, or they didn't want to give up this special sauce that they had built into their PLM systems to move forward. So for Aras, the what if was this vision of a real no-compromise SaaS-based, SaaS-delivered PLM that accounts for all the things that were required, including the customizations that our community knows and loves. So we launched that global modern SaaS offering with global scalability and security, and importantly, support for DevOps in order to get through that customization and make sure it happens in a scalable, secure, and resilient manner. We're not stopping here, of course. This continues to evolve. Stay tuned for more and more. I think there's a product session about our SaaS offering. You can learn where we're going from here. But I think the future is very bright, and it should be focused on cloud technologies. This will evolve, I believe, extensively over the next few years. So that brings us forward to today. And now our question is, what if you could extend the reach of the digital thread? And what do we mean by that? The reach of the digital thread is beyond the four walls of your company. The reach of the digital thread is to get out into the supply chain and other value chain partners. It is to get out to different phases of the product lifecycle, and it's to reach more and more disciplines that would need to be involved in the design, development, and manufacture of a product. So extending that reach means that we need to pay attention to things, the elements of the Aras effect, the openness, the connectivity, the scalability, the adaptability. All these things are important to extending the reach of that digital thread. And in terms of how this manifests itself today, you see things like Build with Aras to have a broader suite of capabilities that are built on the platform. You see things like the supplier management solutions to bring in your supply chain, and the Aras portal to be able to provide a simplified experience for those types of users. And today, of course, we're talking all of this in the context of this thing called Innovator Edge. Now, I know you probably heard a lot about this yesterday, so I'm not going to spend a whole lot of time on it. But I do want to just spend a moment to help you understand how important this is to the future strategy of Aras, right? It is the way forward for extending the reach of the digital thread through connections to other enterprise systems, through AI and analytics, through portals for external users, and through task-focused applications or micro apps, if you prefer that terminology. All these use cases are really built to extend that reach of the digital thread. And we're very excited about the future. And really everything that I'll talk about on stage here, and everything that we'll talk about in our Aras Labs breakout session later on today that I'm hosting, will be based on this concept of Innovator Edge. So really important for the future. So we talked about this idea of connected intelligence. What does that mean? To me, it means putting together the idea of digital thread and AI. Put the two together and you get connected intelligence. And so you'll see Aras deliver new AI-powered capabilities along the 3 dimensions you see here. The first wave of capabilities that we're working on now, you see in the short-term product roadmap that will be released, or actually in beta now. These things are on the discover wave. And really, this wave is about getting a better understanding and a better ability to analyze the data that's already in your digital thread. So it's being able to take all that data that is in your PLM and related systems and be able to have a conversation with your data, to be able to learn more about how to achieve particular use cases. Those are all along that discover kind of dimension. The next wave of capabilities will be focused on enriching your digital thread. This is like being able to connect more data, more people, and more of your business to the digital thread. The idea of enriching your digital thread is really about building a more complete digital thread, probably in dimensions that you might not have even considered yet. This is where you're able to capture a more complete thread by having more people and more use cases contributing to it. Now, the last wave is what we call amplify, and I think this is where a huge amount of business value is going to come through. This is where you can maximize the impact of your digital thread to drive next level innovation in your products. So this now isn't about just the internally focused, discovering things on the digital thread or enriching the digital thread. This is now taking the rich digital thread and being able to amplify your product development, product manufacturing, service, the whole product lifecycle, amplify the effects of the digital thread throughout that. And really, this is about being able to deliver better products by setting AI loose on that rich set of data, being able to innovate more quickly, and with the assistance of AI, putting more power into the hands of your engineers. And so Aras is pursuing all 3 of these waves simultaneously. You'll see the first capabilities in Discover, the next set of capabilities in the Enrich wave, and the third set of capabilities in the Amplify wave. But we're not going to ever stop working on all 3. So this is how we see AI really impacting the future of PLM. Let's double click on these a little bit. So, if we're going to discover digital thread insights, we're going to need help from a few types of AI technology. So we'll need something like natural language search to enable a more conversational interaction model. So users will be able to talk with their data, talk with the documentation, ask questions that might trigger some analytics. Those are all powered by natural language search. Content synthesis is really the ability to summarize data that comes from different parts of the digital thread, bring those pieces of data together, and provide some level of summarization to put it in the language of the user that asked the question. So that really, it's about taking data from different parts of the digital thread and communicating it effectively. Of course, machine learning has been around a while. This is what enables us to identify patterns and trends within the digital thread. So as you get a richer and richer digital thread, you'll be able to deploy machine learning to do more and more pattern recognition. And the last one, text to SQL or SQL, that is a bit of a misnomer, but this is the ability to prompt, to have a natural language prompt that gets converted into a query. So it gets converted into a query such that the data itself never needs to be exposed to AI. The data is hidden from that. The impact of the text to SQL is really that the AI is able to take your question, show me all parts that cost more than $100 that are also blue. It can convert that into a query that can then be executed against live data. So this is an important part of the Discover wave. So we'll get to the what ifs now. So what if you could get a guided tour of how to set effectivity conditions to synchronize multiple changes? So let's say you're planning a series of interdependent engineering changes that impact multiple suppliers. You work maybe on multiple programs. You don't remember exactly how to write the effectivity conditions for this particular government contract. If you had the ability to ask, then you're not sitting there sifting through a bunch of product documentation and procedure documents to figure out how to set the effectivity conditions correctly for this particular change. You're going to get context-aware help. Right? The advice that you get is going to know which contract you're working on. It's going to understand the contract procedures, and it will provide you with the information, only information that's relevant. You can get examples from other similar changes delivered through AI to be able to have an example for writing those conditions. So that means you can avoid the trial and error and error-prone process of trying one way. If that didn't work, then try another way, possibly having downstream impacts. And in the end, you can phase in your changes with confidence, knowing that you're not going to have a bunch of rework and scrap, and you're not going to have supply chain conflict by ordering incompatible parts in from different suppliers that won't work together after the change. So this is really what if you could leverage the power of AI to help you execute changes more effectively. The next one on the discover dimension is really, what if you could assess the global supply of a source component before submitting a change request? So before I even hit the save button on my change request, I could get information that tells me how many of these parts or components are in inventory at factories globally. How many are currently being assembled into products, and how many are out there in the field already deployed to customers that we need to think about service. So imagine an engineer proposes a component change to improve the product performance, but he has really no visibility into the implications in the supply chain to know whether it will be a good idea or whether it's something that should probably wait. So in this case, we could have a natural language prompt that can traverse the digital thread, figure out all the inventory globally, figure out of the component to be replaced, figure out where the new component could be sourced from, understand the details of supplier contracts and how many are already on order, and figure out if there are any other uses of the currently sourced part that would need to be accounted for reuse purposes. And in the end, you'd avoid wasting time on pursuing changes that may seem like a good idea at first, but would not have a proper return on investment. And I think we've probably all seen this in our careers where engineers come up with brilliant ideas, they submit them, we find out only later that how much it actually cost the company to optimize that one component improvement instead of optimizing for the entire product, including the supply chain. And lastly, on the discover dimension, what if you could ask your AI assistant to identify common factors when performing a root cause analysis? So let's say you have a product failure. It looks like there's some commonality with other product failures, but you would have to spend days or weeks to really understand what the commonality between them. What are the patterns? What if with one question you could ask AI to go figure out why what all these problems have in common during a root cause analysis? If you did that, you'd be able to analyze and resolve issues much more quickly. and you'll be able to have a higher level of quality because you're not spending your time chasing this root cause and that root cause. You're able to do it very quickly. And in the end, we believe that's going to result in customer sentiment improving because not only do you understand the root cause of these problems more quickly, that's going to lead to fixing more problems more quickly because the less time you spend fixing one problem, the more time you have to fix the next one. And so in the end, we believe this will result in persistent quality issues being a figment of the past. It would not be, we would not have those failures that continue to occur because we'd be able to perform root cause analysis more effectively. If we look at the next dimension, which is the enriched dimension, we'll need some AI techniques and technologies to be able to achieve this. So enriching your digital thread can be achieved with several of these techniques and of course some others. So entity recognition is this natural language processing technique that identifies and classifies entities like people, organizations, locations, dates, etc. Right? So within, if you have a reference to a customer inside a document, or you have a reference to a factory that's inside some PDF somewhere, this entity recognition is going to be able to figure out that that's actually referring to an element of the digital thread. We can make those connections quite easily. We can leverage things like contextual reasoning to understand not only that things are related to one another, but why they're related to one another. That's really what the contextual reasoning is about, is understanding the pattern, not only the pattern itself, but the semantics or the why behind that pattern existing. Something like topic modeling is about automatically identifying and organizing the hidden themes within a collection of data by analyzing the what they call the co-occurrence of words. So let's say I have data on opposite sides of the digital thread. They both have the same word, say aluminum. Maybe one of them is aluminum and the other one's aluminium. We can figure out that those terms are actually related and be able to use that topic modeling to connect that data, even though it doesn't have direct connection within the digital thread. And then, of course, deep learning is getting into neural networks to analyze complex data, to identify really intricate patterns, really dig deep in the machine learning space, and enable accurate predictions for the future. So all these things come together to be able to help us enrich the digital thread further. And so what's that going to drive? Well, what if missing or inconsistent links in the digital thread could be easily identified and corrected? We see this all the time. I know a lot of companies here, for example, have several groups of engineers that do simulation. They do simulation with different technologies in different buildings and maybe in different parts of the world, and they just do everything differently. They then try to attach the results of their simulations to the digital thread, but they do it in inconsistent ways. What if we could use the power of machine learning to get into those patterns, understand the differences of how those simulation teams are working, and be able to drive consistency such that it will be easier for everyone to learn from the digital thread. So that means you're establishing standard practices. You can get things like suggestions for digital thread relationships. Even when I'm just creating something new, I'll be able to get suggestions for what this thing that I'm creating should be linked to. That should be live in the user interface right in front of you. You can have confidence in the results of downstream AI and analytics because you're leveraging the power of AI to create those relationships and correct the relationships that aren't quite right. And in the end, we'll stop wasting effort on redoing prior work. It will always be linked. We'll always be able to find it. You'll never have to redesign the same part again because you couldn't find the old one. You'll never have to redo the previous simulation because your digital thread will lead you to the one that's already been done. Next, we can ask, what if requirements could be automatically identified and ingested from reliable external data sources? So think about this. You get requirements from many different sources. You get requirements from customers. You get requirements from regulatory agencies. You get requirements from your sustainability team. You get requirements from lots of different places. What if instead of only having the ability to type or import those things, what if you had access to external data sources that could bring all those requirements in for you? So think about this. You have a product line, and your job is to launch it into a new market where your company has not competed before. That means you need to account for things like market-specific requirements, the common practices in that market, and things like regulatory requirements. What if, with just a natural language prompt, you could ask what additional requirements would be necessary to account for in this new market? So your AI assistant can then find relevant regulatory documents, link them in, maybe even break those regulatory documents down into chapters and individual requirements to help you better trace your requirements thread. You could get the market-specific practices and preferences identified quickly and transformed into requirements in your format. And you could find very many different data formats and be able to consolidate them together. And so then we believe if we have this, we're going to see next level requirements traceability to dynamic references to evolving market conditions. So as those regulations change, you'll be able to see how individual requirements are impacted and be able to do impact analysis very quickly because you have a very detailed requirements chain. And lastly, on this one, on Enrich, is what if factory floor data could be analyzed and linked to your quality planning parameters? So, for example, you have factory data operations that are connected to, let's say, Microsoft Fabric, and they're monitored using manufacturing data solutions to understand things like the frequency of process failures, the severity of process failures, all the things that we do in failure mode and effects analysis. What if you had actual data to correlate back to your quality planning documents instead of them just being a prediction that no longer that gets forgotten and never revisited? So this means that you can compare actual versus predicted. Your quality practices would be evolving, not staying static. And you can have stronger mitigation techniques for how to fix quality problems and optimize your processes to proactively build these capabilities in. This idea of planning for a feedback loop is a very powerful thing. And the failure modes that are unanticipated, the ones that you didn't put into your failure mode and effects analysis, would easily be able to stand out as anomalies. You'd have data to prove that your FMEA was incomplete. And so in the end, this makes something like quality planning, and this is just one example of many, but this makes quality planning something that would no longer be this theoretical, disconnected practice that happens once and we forget about. It would be a core part of the feedback loop of how to improve my factory, how to improve my manufacturing process. All right, our last dimension that we're going to talk about today is this idea of amplify. Again, we're amplifying the impact of the digital thread to build better product. So here are a few terms you might have heard and maybe not. We certainly hear a lot these days about agentic AI, this idea of autonomous generative agents that execute complex tasks with little or no human supervision. This is always going to be, agents are in the background, monitoring your data, looking for opportunities for optimization. Something like surrogate modeling uses deep learning techniques to create an approximate mathematical model of outcomes. So think about if you operate in a simulation-heavy kind of environment, running simulations often is a very expensive thing. What if you could reduce the simulation, at least at a very simple level, reduce the simulation to a mathematical equation using surrogate modeling? That would allow you to narrow down the design space very quickly and very inexpensively, and then take the next step with proper simulation to verify that those results were correct. We hear a lot about generative engineering. It's really using AI to explore and optimize system architectures. So this is beyond just geometry, generative design. This is really into the systems model and figuring out through AI different ways of solving the same problem. Having different physical implementations of the functions that we need to achieve with our product. Then lastly, I'll mention reinforcement learning. This is what optimizes the strategies for complex design problems. So it's allowing you to explore a very wide design space, balance multiple objectives, and do a multidisciplinary optimization through reinforcement learning. So these technologies and techniques are the things that we believe at this stage. Of course, it's a fast-moving world, and AI is moving faster than ever. But as of now, these are the ones that we're looking at to help you amplify the impact of your digital thread. So then, how would that change your business? How would it be transformative? So what if your engineer-to-order business could be transformed by leveraging all your past engineering work to create a common variability model? This is something that we've already prototyped. Come to the Aras Lab session this afternoon if you'd like to see it. But this is a really cool technique to take years and years of bills of material that maybe are derived from one another. So you start with one design, new customer requirements come along, you hit save as, new requirements come along again, you hit save as again, and you end up with all these bills of material that have a lot of commonality, but a few differences. So what if we were to leverage AI to find those patterns and then generate a breakdown structure and a variability model that would handle all those engineered order use cases using more configured order business practices? This would really be transformative, we believe, to a lot of businesses. So that's going to give us opportunities for reuse, give us opportunities for cost savings, opportunities for quality improvements, and they can then be prioritized and implemented in the context of the entire product line, not an individual bill of material for a specific customer. You'd eliminate all the time you spend chasing down previous engineering work. When some customer requests something that sounds familiar, I know we did that 5 years ago, I don't remember which customer it was for. We spend time chasing down those designs. That would really be eliminated in this case. And then we'd be able to focus on product innovation by optimizing our engineering practices to work on a cohesive and complete product line instead of working on individual engineered order kinds of work. And so this would mean that the engineering work would shift from focusing on the individual customer designs, do less of that, spend all our time improving our product line. If a customer has a requirement that has never come up before, great, we will add it to the variability model. We'll do the engineering work. We'll now change our configurator to be able to provide that option. That world is much more efficient than the world that many companies live in today with the engineered order techniques. What if we could simulate the impact of a proposed change across all functions, manufacturing, quality, supply chain, all of it, before we implemented it? What if, with one question, if an engineer proposes a material change for a component, what if they're asking one question, how would this impact the product downstream processes in manufacturing this product? What if we could ask one question and understand all the impacts? So that would mean that we would eliminate rework. We'd be able to avoid unnecessary changes to contracts. We could optimize change timing to maximize the use of existing components and avoid scrap. We could quickly implement ideas for improvement. So think about how this would change things. Today, if I have an idea for an improvement and it's going to take me 3 weeks to understand the true impact, do I have 3 weeks? If not, I might not do it, right? So this will actually increase the level of innovation. It will increase the proposed changes because they'd be so much easier to understand how those changes would be implemented. And in the end, the ideas would be quickly analyzed instead of being lost due to those time constraints. So drive more and better innovation through the use of AI techniques to understand the true impact of a change downstream. And lastly, what if you could design a product that could automatically adapt to changes in your supply chain? So imagine this. Your product was designed to utilize the latest system on a chip. Great. Advanced technology, we all love it. Systems on chips are great, but supply chains can be fickle. Sometimes those systems on a chip, the price could increase. It's being manufactured in a place that is subject to geopolitical disruption. Pricing could change. Supply could dry up. What if we didn't have a design that was locked into that specific system on a chip, but could adapt to either using the system on a chip or using a series of other chips for processing and RAM and other things, have an alternate solution in the background, such that if there was a supply chain disruption, we could make a change. So in this scenario then, your systems engineering models are accounting for multiple logical and physical implementations of the required functions. If you have disruptions in the supply chain that are caused by regulatory or geopolitical or other kinds of disruptions, they can be managed with a minimal additional effort. And I think importantly to investors in the room, a company's exposure to risk would reduce dramatically if you had ready to go alternate solutions just in case a supply chain disruption came. If you could predict these things in advance, or if you can be at the ready with new designs, that means that the revenue stream is unlikely to dry up, even if something big changes, because you have those alternates on the ready, on orbit spares, as we used to say in my early career in the satellite industry. And that means that costs can then be optimized at the product level instead of focusing on each individual component. So if my design knows that I can either have a system on a chip that costs $5 or a series of individual chips and a PCB that maybe costs $6, if the system on a chip price suddenly goes up, I can now optimize my entire product design instead of just continuing to hammer the supplier of the system on a chip to give me better prices because that's my only option. Now I can optimize at a different level and achieve better profitability over time.